let's take a look at quadratic shifts. And for all of these problems, the leading coefficients are either going to be a positive one or a negative one. So they're all going to have the general shape. What I want to focus on is how are these equations, how are they altering the vertex? So if we look at this is our parent function, f of x is equal to x squared, and it looks something like this, with my vertex at 0, 0. Right. This next equation is a little bit different. I have x minus 1 squared, and there's a plus 0 over here. Whenever you have an x minus 1, what you want to do is take x minus 1, set it equal to 0, and solve that, and you get x is equal to 1. That means my vertex has shifted on the x-axis 1 to the right. All right, it's at 1. My axis of symmetry is at x is equal to 1, and from here it's going to take the same general shape as the parent function. All right, if we look at f of x is equal to x plus 2 squared, we're going to take x plus 2, set it equal to 0, and solve that, and we get x is equal to negative 2. So now I've shifted 2 to the left, and the same basic shape. Right. This last example over here, this is a negative 1, so this is actually going to face down, but the same concept applies. The vertex is going to shift 4 units to the right, and it's going to open down. All right. Let's take a look at this next row where I'm not altering the x. I'm actually going to alter what's hanging on the end there. So we have our parent function, f of x is equal to x squared, which looks something like this. Now, like I said before, these are a little bit different than the ones above because I'm not altering the x. If I plug a 0 in for x, suppose I made a table, and I plugged a 0 in. I get 0 squared and 0, I get negative 3. My vertex has now just shifted down 3 units. All right, and it's the same basic shape as the parent function. For this one, if I plug in a 0, if I made a table, I'd get a 2 out. So it's shifted 2 units up. And for this last one, it's going to shift up 1 unit, but I have a negative x squared, so that means it's going to open down. And what we're going to do here is we're going to combine the two. So here I have my parent function, x plus 2, that means I'm going to shift to the left 2, and I'm going to shift down 1. So to the left 2 and down 1. It's a positive 1 right here, leading coefficient, so it's going to open up. This third one, I'm going to shift to the right 1, and I'm going to shift down 2. The leading coefficient is still a positive 1, so it's going to open up. And then the last one, I'm going to shift to the left 3, and I'm going to shift up 1. This is a negative, so it's going to open down.